Mm. Hello everyone, welcome back to the 21st Century Academy. My name is Chetan Maru. Okay, so now in this video, we'll learn about this third chapter of Geography of NCERT book of Fundamentals of Physical Geography. Okay, and this is 11th class Geography NCERT book. Okay, and as you can see, the chapter name Interior of the Earth. Okay, so no further ado, let's begin. Okay, so what do you imagine about the nature of the Earth? As we have been given the question. Okay. So, do you imagine it to be a solid ball like a cricket ball or a hollow ball with a thick cover of rocks? I can just say that lithosphere. Okay. And another we have a given question is have you ever seen photographs or images of a volcanic eruption on the television screen? Okay. Just like this, another question, can you recollect the emergence of hot molten lava, dust, smoke, fire, and magma flowing out of the volcanic crater? Okay, and now moving ahead, as you can see, that the interior of the Earth can be understood only by indirect evidences, as neither any of one has nor anyone of can reach interior of the Earth. Okay, so no one can reach in to the interior part of the Earth, and that's why we are not able to get any of the information just our own visit. Okay, so we'll have or whatever the information I will get from direct or indirect sources, but not is that is not based on physical appearance or being there. Okay, so here we have been given or explained. Okay, so now we'll learn each section. Okay, step by step. So the configuration of the surface of the Earth is largely a product of the process operating in the interior of the Earth. Okay, so whatever we see on the surface of the Earth is the process of that operating in the interior of the Earth is the product of that. Okay, so exogenic as well as endogenic process are constantly shaping the landscape. Okay, as we have a number of landscape. Okay, mountain plateaus. Okay, so these are the landscape. Okay, and we know that how they are uh, changing or being shaped by this both endogenic and exogenic process. Okay, so endogenic is which is from inside of the earth. I mean the pressure or the forces that acts from inside, and the exogenic that is means outside. Okay, a proper understanding of the physiographic characteristics of a region remains incomplete if the effects of the endogenic process are ignored. Okay, obviously, the part of this endogenic is important in the formation or complex understanding of this landscape feature. Okay, and now if okay, human life is largely influenced by the physiography of a region. Okay, of the region. Therefore, it is necessary that one gets acquainted with the focus that influences the landscape development to understand why the earth shake or how tsunami waves is generated. Okay, so it is necessary that we know the certain details of the interior of the earth. Okay, so it is quite important for us to know. In the previous chapter, you have noted that the earth forming materials have been distributed in the form of layers from the crust to the core. Okay, and it is interesting to know that. The scientists have gathered information about these layers and what are the characteristics of each of these layers. Okay, this is exactly what we will learn or will deal in this chapter. Okay, so now we'll go by step with this. And here, as we have given the sources of the information about the interior. Okay, so what sources we have about the interior of the Earth. Okay, and I will draw some light. Okay. Okay, so that it will be quite easy for you to understand. Okay, now moving this will change for reading. Okay, so the sources of information about the interior. Okay, I will get to know about the interior. What is there? Okay, inside. So the Earth's radius is about 6,378 kilometer. Okay, and this is a quite factual question. So factual point you can remember it because this thing can be asked in multiple question answer. Okay, MCQ type of questions. Okay, so no one can reach the reach the center of the Earth and make the observation or collect samples of the material. Okay, under such conditions, you may wonder how the scientists tell us about the interior and the type of material that exists at such depths. Okay, most of the okay, I will highlight this. Okay, most of our knowledge is about the interior of the Earth is largely based on the estimate and inferences. Okay, so as we do not have anyone to go deep inside and get to know that what is there inside. Okay, so this is how. Okay, so we have just two sources. Okay, direct and indirect sources. Okay, and from on behalf of that, we try to analyze what is there inside. Okay, so as you can see that here we go. It's the direct sources. Okay, so this was direct sources. I'm moving ahead to this direct sources. Okay, so the most easily available solid earth material. Okay, surface rock or the rock we get from the mining areas. Okay, and this is gold mining of South Africa are as deep as 3 to 4 kilometers. And going beyond to this depth, it is not easy or possible as it is very hot at this depth. Okay, because at every 32 meter inside of the earth, okay, we get 1 degree Celsius. Okay, rise in the temperature. Okay, so on behalf of that, we can say this is not so easy to dig so deep inside. Okay, so besides mining, scientists have taken a number of projects to penetrate depth to explore the conditions in the crust portions. Okay, scientists world over are working on two major projects such as a deep ocean drilling project. Okay, this one and this another one is integrated ocean drilling. Okay, so these two projects are being there in the operation. Okay, and the deepest drill at Kola. Okay, in Arctic Ocean has so far reached as a depth of 12 kilometer. Okay, so this is the deepest drilling up to now that is being done. Okay, so this and many deep drilling projects have been provided large number of information through the analysis of the materials collected at different depths. Okay, besides this, we have also this volcanic eruption. Okay, forms another source of obtaining direct information. Okay, as and when molten materials is thrown onto the surface of the earth, okay, during the volcanic eruption, it becomes available for the laboratory analysis. Okay, and however, it is difficult to ascertain the depth of the sources of magma. Okay, because we don't know, we can't say that from or at what depth this magma is coming out. Okay, now moving ahead to this indirect sources. Okay, this is because that was up to direct sources. Okay, now we go for this indirect sources. Okay, so analysis of the properties of the matter. Okay, indirectly provides information about the interior. Okay, properties mean different types of material that comes out. Okay, that we get to know from there. Okay, so we know through the mining activity. Okay, the temperature and pressure increase with the increasing distance from the surface towards the interior of the earth. Okay, just a few seconds as I said. So moreover, it is also known as that the density of the material also increases with depth. Okay, and it is possible to find out the rate of the changes at these of these characteristics. Knowing the total thickness of the earth, scientists have estimated the value of the temperature and pressure and density of the materials at different depths. Okay, so the details of these characteristics with reference to each layer of the interiors are discussed later in the chapter. Okay. So another sources, okay. Another sources as are these meteors, okay, that at the times of the reach the earth. Okay, however, it may be noted that the materials that becomes available for the analysis of meteors is not from the interior of the earth. Okay, so it is from the space. Okay, or outside the earth. Okay, the material and the structure observed in the meteors are similar to that of the earth because they were formed almost in the same age. Okay, they are solid bodies. Okay, developed out of the material same as or similar to the our planet or the earth. Okay, hence this has become yet another source of information about the earth. Okay, so the other indirect sources include the gravitation, okay, magnetic field, okay, and seismic activities, okay. So these three are another indirect sources. Okay, so the gravitation force G, as we have representation, G symbol, G word, or G, this word has been taken as a symbol for gravitation. Okay, so it's not the same as different latitude on the surface. Okay, it is greater near the pole. Okay, so gravitational force is greater near the poles and lesser at the equator. So this is a quite factual question. Okay, that you need to remember. This is because of the distance from the center at the equator being greater than that of the pole. Okay, so distance at the center or the equator is greater, and that of the poles is less. Okay, so the gravity value also differ according to the mass of the material. Okay, so as we have if a big mass is there, so obviously that will attract or will have a great amount of this gravity. Okay, so uneven distribution of mass of material within the Earth influences this value. Okay, so the reading of the gravity at different places is influenced by many other factors. So these okay, and these readings differ from the expected value. Okay, sometimes we try to expect something, but when we go into actual, we'll get to the another or actual results. So that will be may have different value. Okay, so such differences is called gravity anomaly. Okay, okay. So gravity anomalies gives us information about the distribution of mass of the materials in the crust of the Earth. Okay, so magnetic survey also provides information about the distribution of the magnetic materials in the crustal portion, and this provides the information about the distribution of materials in part. Okay. And seismic activities is another most important source of this interior of the earth. Okay, and now moving on to another topic, that is earthquake. Okay, so what is earthquake? Okay, so the study of the seismic waves provides a complete picture of the layer interior. An earthquake is in simple word is shaking of the earth. Okay, okay, let me use another color that is yellow. Okay, it is okay. Geographic. Hmm. Yeah. The study of the seismic wave provides the complete picture of the interior of the Earth. Okay, interior layer. Okay, what is there inside? Okay, so what is earthquake? So in simple word, it is the shaking of the Earth. Okay, emotions inside the Earth. Okay, so it is a natural event. Okay, caused due to release of energy and which generates wave that travels in all directions. Okay. So why does the earth shake? Okay, so the release of energy occurs along a fault that occurs, and why this fault takes place because of sharp break in the crystal rocks. Okay, and rocks along a fault tend to move in opposite direction as the overlying rock strata press them. Okay, and the friction locks them together. Okay, however, their tendency to move apart at some point of time overcomes the friction. So, as a result, the blocks get to deform and eventually they slide past one another abruptly. And this causes a release of energy, and the energy is to travel in all directions. And the point from where the energy is released is called the focus of the earth. Okay, so this is quite important factual question thing that you always need to remember what is focus and what is hypocenter. Okay, so the point where the energy is released is known as this focus of the earth. Okay, or alternatively we also sometimes refer it as hypocenter. Okay, and the energy, okay, this hypercenter, okay, this one, okay. So the energy wave traveling in different directions to reach the surface, and the point where the surface nearest to the focus is called epicenter. Okay, so epicenter or this hypocenter or this your focus. Okay, So focus, hypocenter are the same, okay, and epicenter is nearest place or perpendicular to the focus is the place that experience first time this earthquake. Okay, the epicenter is what, and this first one to experience the waves. Okay, so it is a point directly above the focus. Okay, now moving ahead to this earthquake waves. Okay, because we have number of waves that forms when this earthquake take place. Okay. No, yes. So all natural earthquake take place in lithosphere. Okay, it is sufficient to know that the lithosphere refers to the portion. So this is bounded up to 200 kilometer from the surface of the earth. Okay, so this is the boundary of this lithosphere where this earthquake takes place. Okay, so an instrument called seismograph. Okay, seismograph is kind of instrument that records the waves that reaching the surface. Okay, so this is also another important fact. Okay, a curve of earthquake waves are reported on the seismograph. Okay, and moving to note that the curves show three distinct sections, each representing different types of waves. Okay, waves pattern. Earthquake waves are basically of two types. Okay, body wave and surface waves. Okay. So body waves are generated due to release of energy at the focus and move in all direction traveling through the body of the earth. Okay. Hence the name hence the name of the body. Okay. So because it moves in all direction. Okay. So the body waves interact with the surface rocks and generate a new set of waves. Okay, and that is we call surface waves. Okay. So these waves move along the surface. Okay. Means outer surface of the part. Okay. And the velocity of the waves changes as they travel through materials with different densities. Okay, because all materials have different densities. Okay, all materials don't have the same density. Okay, because of their constituent part vary in their density. Okay, so the denser material has the higher velocity, and their direction also changes as they reflect or refract when coming across material with different densities. Okay, so we have generally P wave, S wave, and surface wave. Okay. So there are two types of body waves. Okay. So they are called P wave and S wave. Okay. So P wave move faster. Okay. And the first to arrive the surface. Okay. And these waves are also called as primary waves. Okay. P waves are similar to the sound wave because it moves or have this moving capacity just like a sound. Okay, so they travel through gaseous, liquid, solid material. Okay, means all three forms of material. Okay, while as waves arrive at the surface with some time lag, means it doesn't come at the same pace, just like a PV. Okay, so it is having a less speed or slow speed. Okay, so they are known as, this one is known as secondary waves. And important factor about this as wave is that they can only travel to solid material. Okay, right. And this characteristics of S wave is quite important because it helps the scientists to know and not to know scientists to understand the structure of the interior of the earth. Okay, because one way P wave is moving in all the direction or means passing through all the this materials, while S wave is only through this solid. So that means there is something inside that is making scientists to believe that all parts inside the earth are not of the same density. Okay, so reflection causes waves to rebound, whereas refraction makes waves move in different direction. Okay, so two terminologies are there. Okay, reflection, okay, causes waves to rebound. Okay, so for example, if the waves are coming, okay, and if they are striking, they will rebound, means come down. Okay, and this another one is a reflection when the wave is moving in different direction. Okay, not just in one single direction. Okay, the variation in the direction of the waves are inferred with the help of their record on the seismograph. Okay, how we get to know? This is based on the record on seismograph. Okay, the surface waves are the last to report on the seismograph. Okay, so this is the last one. Okay, these waves are more destructive. Okay, surface waves are more destructive. Okay, property and life as well. Okay, so they call the displacement of rocks. Okay, hence the collapse of the structure circle. Okay, so that we saw generally that whenever earthquake comes, we saw the collapse of building or some other, so, loss of life and yeah, kind of phenomena associated with that. Now moving ahead, the propagation of earthquake. Okay, how do they propagate? Okay, that is there's the point. Okay, okay, different types of earthquake waves travel in different manners. Okay, as we just read. Okay, so as they move or propagate means they are how they are just moving here and there. Okay, so they cause vibration. Okay, in the way of as they are moving. Okay, of the rocks through which they pass. Okay, so P waves vibrate parallel to the direction of the waves. Okay, and this exerts pressure on the materials in the direction of the propagation. Okay, so as a result, it creates a density differences in the material leading to the stretching and squeezing of the materials. Okay, and stretching and squeezing. Another three waves vibrate perpendicular to the direction of the propagation. Okay, the direction of the vibration of S wave is perpendicular to the wave direction. Okay, in vertical plane. Okay, and hence they create trough. Okay, and crest. Okay, just waving structure. Okay. Uh, in the material through which they pass. Okay, and surface waves are considered to be the most damaging waves. Okay, so this was about their nature of propagation. Okay, now talking about the emergence of this shadow zone. Okay, shadow zone is just originated because of this differences in the material. Okay, as we know, this P wave and S wave. Okay, just let's read. Okay, so the earthquake waves gets recorded on seismograph located at far off location. Okay, so however, there exist some specific areas where waves are not reported. Okay, such zones are called shadow zone. Okay, so what is shadow zone? Okay, so there are some places where all the waves do not reach. Okay, such zones are called shadow wave. Okay, the study of different events reveals that for each earthquake there exists an altogether different shadow zones. Okay, so what is saying here? The study of different events reveals that for each earthquake there exists altogether different shadow zones. Which, all does not have the same shadow zone. Okay, so here it is obvious. It is okay. Okay, figure 3.2. Okay, we'll see into that. Okay, moving ahead. We'll see that also. So let me take. Okay, figure 3.2. Okay, we'll see that. And it was observed that the seismograph located at any distance within 1.105 from epicenter recorded the arrival of both P and S wave. Okay. However, the seismograph located beyond 145 from epicenter record the arrival of P waves, but not that of S waves. Okay. Thus, the zone between 105 and 145 from the epicenter was identified as the shadow zone for both types of waves. Okay, the entire zone beyond 105 does not receive S wave. Okay, the shadow zone of S wave is much larger than that of P waves. Okay, and the shadow zone of P wave appear as a band around the Earth between 105 and 145 away from the epicenter. Okay, the shadow zone of S wave is not only larger in the extent but is also a little over 45 or 40% of the Earth's surface. We can draw a shadow zone for any earthquake, provided you know the location of center. Okay, so we'll see that in the picture, then we'll get to know in much more clear way. Okay, so now we have been given here types of earthquake. Okay, the most common ones are the tectonic. Okay, like me just make a point. So how many types of earthquake? Okay, so tectonic earthquake. These are generated due to sliding of the rocks along the fault line. Okay, fault plane. Okay, and another one is a special class of tectonic earthquake is sometimes recognized as volcanic earthquake. Okay, and is confined to the volcanic activity or active volcanic area. Okay, so here we have been given the figure. Okay, okay, just let me go with this another. Okay, two. After that. Okay, yeah, it is here. So in the areas of intense mining activities, sometimes the roof of the underground mines collapsed, and this is called minor tremor, causing the minor tremor. Okay, okay, and this is called the earthquake. Okay, collapse earthquake. Okay, in mining areas. Okay. And now another one is ground shaking may also occur due to the explosion of chemical or nuclear devices. Okay, so we also know this kind because nowadays this thing is happening. Happening in the sense means so many natural this just like North Korea and some other countries are trying to show for that they are nuclear power. So just they are also having this if they are having this kind of nuclear weapons, so if it is being leakage. Okay, so this will cause explosions, obviously will cause earthquake. Okay. And another one is the earthquake that occurs in areas of the large reservoir. Okay, so we know the dam where. Okay, so reservoir induced earthquake that we refer. Okay, so now moving to this diagram. Okay, so as we can see that this is the shadow zone of this hmm, this one is the shadow zone of this p wave. Okay, from 145 or 105 to 145. Okay, this is shadow zone. Okay, for p waves. Okay, and while we also have this 1 to 15. Okay, okay, for s wave this is a shadow zone. Okay, because of the density in the material is different. So this is how, because the P waves can reach to all materials, and one thing is noticeable that when this P waves moving to the liquid part, so its speed or velocity gets slowed down. Okay. However, S wave cannot move to the liquid materials. Okay, or liquid state. Okay. So this is there. Okay. Now we will go to another part. Okay. So measuring of earthquake. How do you measure? Okay. Well, mhm. What do I need? Mm, okay. So measuring of earthquake. Okay. The earthquake events scale either according to the magnitude or intensity of the shocks. Okay. So the magnitude scale is known as the Richter scale. Okay. So this is very common to measure this earthquake. Okay. And the magnitude relates to the energy released during the earthquake. Okay, so what was the energy that released? So this is on behalf of that, and the range is 1 to 10. Okay, or 0 to 10. Okay, and another we have this intensity. Okay, how intense was the earthquake? So intensity based. Okay, intensity scale. Okay, that is we recognize as Mercalli scale. Okay, okay, and it was Italian seismologist. Okay, he was an Italian seismologist. Okay, so that intensity scale takes into account the visible damage. Okay, so that we see by our new dice. Okay, what is damage there? So this is on behalf of that, and the range is 1 to 12 here. Okay, so this is a quite factual thing that we always need to remember when it comes about the measuring of the earthquake. So Richter scale and Mercalli scale. Okay, and Richter scale is based on this magnitude. Okay, and the Mercalli scale is for intensity measurement. Okay, and this has a value of 1 to 12, while this Richter scale has 0 to 10. Okay, so now moving ahead to another part is effects of earthquake. Okay, so the earthquake is a natural hazard. Okay, and this the effects. Okay, what are the effects? Okay, it's a ground shaking, differential ground settlement. Okay, and land and mudslide. Okay, so these are quite understandable thing. Okay, that we generally can observe, and we know this. Okay, and soil liquefaction and ground lurching. Okay, avalanches, ground displacement, flood from dam and levee failures. Okay, fires, structural collapses, falling objects, tsunami. Okay, so however, here we have to notice this first six. Okay, first six. One, this ground shaking, differential ground settlement, land and mudslide. Okay, soil liquefaction. Okay, ground lurching and avalanches. These are some bearing upon the landforms. Okay, while other may have considered as effects causing immediate concern to the life. Okay, and properties of the people. Okay, because these are happening because of this human settlement areas. Okay, because this can be of in any of the natural area. Okay, where there is it is not necessary that always having a human settlement, but in most of this area means of this ground displacement or flood from dam. Okay, so this is a settlement area. Okay, so if it is happening in nearby this area, okay, obviously this will cause immediate concern to the life and properties of the people. Okay, that region. Okay, so the effect of the tsunami would occur only if the epicenter of the tremor is below the oceanic water. Okay, and the magnitude is sufficiently high. Okay, tsunamis are generated by the tremors and not the earthquake itself. Okay, so here we have to remember this fact. This tsunami are waves generated by the tremors. Okay, and not an earthquake in itself. Okay, so this is based on tremors. Okay, so though the actual quake activity lasts for a few seconds. Okay, because the earthquake doesn't take for like a minute or 2 minutes, 10 minutes, okay, 10 minutes. Okay, so it is just for a few seconds, a couple of seconds. Okay, so its effects are devastating provided the magnitude of the quake is more than 5 on the Richter scale. Okay, so here have some glimpse of this natural disasters. Okay, so a view of destruction caused by the tidal waves in Mariana Beach, India. Okay, and this people walk through the debris of their house destroyed tidal waves on the coastal area of Colombo in Sri Lanka. Here we have this Andaman, Nicobar, Andhra. Okay, and this coastal areas. Okay, they are most vulnerable or this kind of phenomena because the coastal area will have this devastating because the tsunami 2004 we know is based on earthquake. Okay, a view of destruction caused by the tidal waves in Thailand. A view of the destruction caused by the tidal waves in Indonesia. Hmm. Okay, now moving on to another subtopic is frequency of earthquake. Okay, or the occurrences. Okay, so the earthquake is natural hazard, and if a tremor is higher takes place, it can cause to heavy damages. Obviously, quite obvious to know, right? However, not all parts of the globe necessarily experience the major shocks. Okay, so we shall discuss the distribution of the earthquake and volcanoes with some details in the next one, next chapter. Okay, so note that the quake the magnitude is F 8 plus. Okay, because these are quite rare, and if it is there, so that is quite devastating. Okay, so they occur once And hmm, so they occur. Mhm. Okay, they occur once or twice in a year. Okay, and those of tiny types occur almost every minute. Okay, because they are not so perceivable. Okay, and we don't have any such effects from that. Okay, the structure of the Earth, the crust, mantle, and the core. Okay, so outermost part of the solid Earth is known as the crust. Okay, it is brittle in nature, means it can be break. Okay, the thickness of the crust varies under the oceanic and continental areas. Okay, oceanic crust is thinner as compared to the continental part. Okay, and the mean thickness of the oceanic crust is 5 kilometer, whereas the continental is about 30 kilometer. Okay, the entire line are important here in this. Okay, 5 kilometer, and the continental crust is thicker in areas of major mountain, and it is as much as 70 kilometer thick in the Himalayan region. Okay, and now we're talking about this mantle. Okay, in Hindi we say it pravar. Okay, the portion of the interior beyond the crust is called mantle. Okay, so beyond the mantle, it is called, and mantle extend from Moho discontinuity to a depth of 2900 kilometer, and the upper portion of the mantle is called asthenosphere. Okay, then this is the layer where all the magma is originate. Okay, it is also referred to as a magma chamber. Okay, so word astheno means weak, means okay, not so strong. Okay, it is a weak astheno means, and it is considered as up to be extending to up to 400 kilometer, and is the main source of magma. Okay, so we have been given this crustal core. Okay, so 6,378 kilometer to the core. Okay, and this 2,900 kilometer to the mantle, and 0 to 100 this crust. Okay, as you can see, okay, in this picture, 3.3 interior of the earth. Okay, and this hide. Okay, hmm. So it is the main source of that finds its way to the surface during the volcanic eruption. Okay, when that lava it forms, it is known as lava when it comes on the surface, while when it is inside of the earth, then it is known as magma. Okay, so the crust and the upper part of the mantle is called lithosphere. Its thickness ranges from 100 this 10 to 200 kilometer. Okay, lower mantle extends beyond the ionosphere. It is solid state. Okay, and now moving ahead to this core. Okay, so as indicated, the earthquake waves velocities help to understanding the existence of the core. Okay, and the core. Okay, understand the core and the mental boundaries. Okay, located at the depth or below this 2,900 kilometer, the outer core is liquid. Okay, is in liquid state. Okay, the core is also divided into two parts: outer core and inner core. Okay, so liquid state is the outer one. Okay, and inside or inner core is in solid state. Okay, so the core is made up of very heavy materials, mostly constituted of nickel and iron, and sometimes referred to as nickel layer. So volcanic volcanoes and volcanic landforms. Okay, so okay, so a volcano is a place where gases, acids, or molten rock material, lava escapes to the ground. Okay, comes out on the surface. Okay, so a volcano is also called active volcano if the materials mentioned are being released or have been released out in the recent past. Okay, and the layer below the solid crystal is mantle. Okay, and it has a higher density than that of the crust. Okay, mantle has higher density than that of the crust. Okay, the mantle contains the weaker zone and is called as a asthenosphere. Okay, and it is from this molten rock materials points their way to surface. Okay, materials in the upper mantle portion is magma. Okay, and once it starts moving towards the crust, it is reaches the surface. It refers to as a lava. Okay, and the materials that reaches the ground include the lava flows, pyroclastic okay, debris, volcanic bombs, ash, okay, dust, and gases such as nitrogen compounds, sulfur compounds, minor amounts of chlorine, okay, hydrogen, argon, okay, volcanoes, okay. Another topic, okay, that we have here, volcanoes. Okay. So volcanoes are classified on the basis of the nature of the eruption and the form of developed at the surface. Okay, so major types of volcanoes are as follows. Okay, so these are the types of volcanoes. Okay, so shield volcanoes. Okay, shield volcanoes. Okay, so bearing the basalt flows, the shield volcanoes are the largest. Okay, shield volcanoes are the largest volcanoes on the Earth's surface, and this example is Hawaiian volcanoes. Okay, are the famous one, Hawaiian volcano. Okay, shield volcano. This is the picture. Okay, and cinder cone. Okay, so example of these volcanoes are mostly made up of the basalt. Okay, a lava that is very fluid when erupted. Okay, for this reason, those volcanoes are not steep. They become for this reason these volcanoes are not steep. They become explosive if somehow water gets into the vent. Okay, otherwise they are characterized by low explosivity. Okay, explosivity. Explosivity. Okay, the upcoming lava moves in the form of the fountain. Okay, and throws out the cone at the top of the vent and develops into cinder cone. Okay, so now another one is we have this cinder or this composite one. Okay, okay, these volcano these volcano are characterized by the eruption of cooler and more viscous lava. Okay, then basalt. Okay, this is a thick one. Okay, so these volcanoes are often result in the explosive eruptions. Okay, and along the lava large quantities of pyroclastic materials, ashes and their way to go ashes find their way to the ground. Okay, these materials accumulates in the vicinity of the vent opening. Okay, leading to the formation of layers, and this makes the mount appear as composite volcanoes. Okay, and another one is caldera. Okay. Um, okay, so these are the most explosive. Okay, the Earth's volcanoes. Okay, and they usually are so explosive that when they erupt, they tend to collapse and themselves rather than building any other tall structure. Okay, so this is another kind of caldera, this volcano. Okay, and collapse or depression are called caldera. Okay, and their explosiveness indicates that the magma chamber supplying the lava is not only huge but also in the close vicinity. Okay, quite near. Okay, and now moving ahead, this another one, flood basalt provinces. Okay. These volcanoes outpour the highly fluid lava that flows for long distances. Okay, some parts of the world are covered by thousands of square kilometers of thick basalt lava flows. There can be a series of flows with some flows attaining the thickness of more than 50 meters. Okay, and individual flows may extend for hundreds of kilometers. The Deccan Traps from India, presently covering most of the Maharashtra plateau, are much. Okay, so now moving ahead to another one. Okay, let me read. This one. Is. Okay, so this one is individual flow may extend for hundreds of kilometers. The Deccan Trap from India, presently covering most of the Maharashtra plateau, are much larger flood basalt province, and it is believed that initially the formation covered a much larger area than the present. Okay, so now moving ahead to another topic is this one is the mid-oceanic ridges. Okay, mid-oceanic ridge based of volcanoes. Okay, and this one is these volcanoes occur in the oceanic areas, okay? And there is a system of mid-oceanic ridges more than 70,000 kilometers long that stretch through all oceanic basins, and the central portion of this ridge is experiences frequent eruptions. So we shall discuss in detail in the next chapter, okay? So now we this one, okay. So another topic is volcanic landforms. Okay, so we have two types of landforms. In major means we categorize this at- in major form as this landforms. Okay, so one is intrusive landform, another one is extrusive. Okay, so the lava that is released during the volcanic eruption are cool eruptions on cooling develops into igneous rocks. Okay, so how do you get to know this igneous rock? This is on cooling of this volcanic eruption based materials. Okay, and the cooling may take place either on reaching the surface or also while the lava is still in the crustal portion. Okay, depending on the location of the cooling of the lava, igneous rocks are classified as volcanic rocks. Okay, and volcanic. Just hold on for a second. Depending on the location of the cooling of the lava, igneous rocks are classified into volcanic rocks and plutonic rocks. Okay, so volcanic is at the cooling on the surface, and plutonic is on cooling in the crust. Okay, within means inside. So the lava that cools within the crustal portion assumes different forms. Okay, and these forms are called intrusive forms. Sometimes some of the forms. Some of the forms are shown in the figure 3.4. Okay, so we have been given here composite volcano, lava mesa, cinder cone, lava plateau, ash cone with volcanic dome, volcanic neck with the radiating dikes, caldera with a cinder cone on floor. Okay, so we have this batholith. Okay, so this is a type of this volcanic landforms. Okay, so batholith. So batholith is what? A large body of magnetic materials. Okay, magnetic materials that cools in the deeper depth. Mm, okay. A large body of magnetic materials that cools in the deeper depth of the crust develops in the form of large domes. Okay, so they appear on the surface only after the denudation processes remove the overlaying materials. Okay, so denudation means a denude. Okay, means uncover. Okay, means with the erosion activities it comes out. Okay, and are quite visible. Okay, so they cover large areas. They cover large areas at times, assumes that the depth may be several kilometers, and these are granitic bodies. Okay, and batholiths are cool portion of magma chamber. Okay, and another form we have this leccolith. Okay, these are large dome-shaped intrusive bodies with a level base. Okay, because from deep it is a base level. Okay, and connected by pipe-like structure conduit. Okay, from below. Okay, and resembles the surface volcanic domes of composite volcanoes. Okay, and all they are located at a deeper depth. Okay, and can be regarded as a localized source of lava. Okay, its way to the surface, and this Karnataka plateau is spotted with the domal hills of granite rocks, and most of these now exfoliated, okay, and are examples of laccoliths or batholiths, okay. Another one is we have this locolith, fecolith, and sills, okay. So, as and when the lava moves upward, a portion of the same may tend to move in horizontal direction. Whenever it finds a weak plane, okay, it may get rested in different forms, okay. And in case it develops into a saucer, okay, shape concave to the sky body is called lapolith, okay. And away mass intrusive rocks at times it found, okay. Hmm. So a mass of intrusive rocks at times is found at the base of the sink line, okay, at the top of the anticline, okay, means it is a deep, when we have this base, okay, so, okay, just like, okay, yeah, this one, okay, so this is a anticline when it is a rising, okay, when it is a decline, means coming downside, so it is a, so sink line, okay, sinking down, okay, so anticline means moving upward, okay, anticline in the fold igneous country, okay. Folded igneous country. Okay, such wavy materials have a definite conduit to source beneath in the form of magma chambers. Okay, subsequently develop as metholiths. Okay, these are called facholiths. Okay, so the near horizontal bodies of the intrusive igneous rocks are called sill. Okay, and or the sheet. Okay, depending on the thickness of the materials, the thinner ones are called sheet, while the thick horizontal deposits are called sill. Okay, so there is a difference. Okay, thin and thick. Okay, so thick one is this sill, and thin one is sheet. Okay, and another one we have this last one is dike. Okay, so now dike. So when the lava makes its way through cracks and the fissure develops in the land, it solidified almost perpendicular to the ground, and it gets cooled in the same position to develop a wall-like structure, and such structures are called dikes. Okay, so these are most commonly found intrusive forms of western Maharashtra. Okay, and these are considered to be feeders of the eruptions that led to the development of the Deccan traps. Okay, so now we have been given exercise, okay, as you can see, and you can you will be quite easily answer. You will be easily answerable to this question once you go through this entire chapter. Okay. So for this video, for this chapter, this was okay, and now we'll get connect in another one. Okay, another video for the another chapter. Okay, and for watching this, thank you. Okay. Yeah.